The Klang Valley Mass Rapid Transit, or KVMRT, is a rail-based public transport that will be the backbone of a new sustainable transport system. MMC Gamuda KVMRT Tunneling Sendirian Berhad was awarded the largest work package by the government to design and construct the 9.5-kilometer underground works for the KVMRT Sungai Buloh Kajang line. The underground tunnel begins at the North Portal in Semantan and ends at the South Portal at Maluri. The tunnel connects 7 underground stations: KL Central, Pasar Seni, Merdeka, Bukit Bintang, Pasar Rakyat, Cochrane and Maluri. All tunnel construction sites were cleared and hoarded according to strict public safety and health guidelines. This commitment to health and safety extends to a special environment management program. In the interest of the environment as well as the public, noise, dust and vibration are all strictly monitored. At each site, safety, health and environment display boards inform the community about the project's progress and allow a greater understanding of how the stations are being built and the various construction techniques used. To ensure minimal disruption during construction, an extensive traffic management program is put into place. Water and gas pipes, communication and electrical cables at sites are relocated. At every site, engineers carry out soil investigations to determine ground conditions. Each station or tunnel shaft has its own retaining walls built according to local soil conditions. KL Central, Pasar Seni, Merdeka, Pudu and Bukit Bintang are all located within the Kenny Hill Formation and hence use the diaphragm wall construction method. To begin with, a guide wall is constructed to set out the position of the diaphragm wall. A trench grab machine then removes the upper level of the soil. At deeper levels, the engineers must resort to using a trench cutter to get through tougher strata. Conditions at different sites mean that a variety of different machines need to be used. Bentonite slurry is used to prevent collapse during construction. The slurry is mixed with excavated rock and soil, then pumped to the surface. Here, the mixture is separated in a special plant, and the recycled slurry recirculated to the excavation trench. The diaphragm wall is formed by a series of individually reinforced concrete panels. A heavy lifting crane lowers the rebar cages into place. Concrete is then poured in to form the panel wall. This process is repeated in sections until the entire length of the diaphragm wall construction is completed. The primary consultant designer for the Kenny Hill section is ACOM. For sites located within the KL limestone formation soil condition, a different method known as secant board piling construction is used to build the retaining walls. These sites include Inai Shaft, Pasar Rakyat, Cochrane and Maluri. First, a guide wall is constructed to set out the position of the secant pile wall. A steel casing is then drilled into the ground. The auger, a drilling tool, then cuts and removes the soil within the casing to form a cavity, into which concrete is poured. This forms a primary borehole. Rebar cages are used for secondary board piles, which are constructed between the primary piles. This process is repeated until the entire length of the secant board pile wall is completed. The main consultant designer for this section of the alignment is Mott MacDonald. To strengthen the retaining walls, ground anchors are used to counter the pressure of the surrounding earth at various sites, including the Semantan North Portal, Cochrane and KL Central Station. The Semantan North Portal, located at the intersection of Jalan Duta and Jalan Semantan, is the launchpad for 2 parallel earth pressure balance TBMs. ancillary structures including the TNB substation were constructed. A muck pit is built to temporarily store material excavated by the TBM before it is removed from the site. At the threshold of the portal, 25 board piles form the foundations of the launching platform for 2 TBMs. The base was then concreted. Parts of the first earth pressure balance TBM from China arrived on site in February 2013. The KL Central MRT station is located at Jalan Damansara and has a construction footprint of approximately 2.25 acres. Work on the site started in April 2012. All rainforest trees on the site were protected. Before the station box was built, an area in front of the National Museum was filled with compacted soil to even out the ground area. A geotextile wall was constructed to secure the earth and control erosion during the backfill process. Construction of the diaphragm wall took 5 months to complete, followed by the installation of ground anchors. Located at a popular tourist area, the Pasar Seni MRT station footprint includes the structures of UO Superstore, Plaza Warisan and Klang Bus Terminal. For public safety, metal scaffolds with peripheral covering as well as catch platforms were erected. Demolition was carried out floor by floor, starting from the top beginning in May 2012 and took 6 months to complete. Construction of the station box progressed in stages, starting with the construction of diaphragm walls at Klang Bus Terminal site. At the Plaza Warisan basement, additional structures were installed. These support the steel decks for heavy machinery needed for future diaphragm wall construction. The Merdeka MRT station construction area measures about 1.85 acres. Preparatory work started in April 2012 and a special ceremony inaugurated the building of the station box 3 months later. The Puru shaft is the launching site for 2 tunnel boring machines to mine northwards towards the Merdeka station. Preparatory works including diaphragm wall construction began in July 2012. The Bukit Bintang MRT station inside Kuala Lumpur's Golden Triangle is at the junction of Jalan Bukit Bintang and Jalan Sultan Ismail. With full possession of the walkway at the front of Bukit Bintang Plaza, all pre-existing structures were removed to make way for a 3-lane road diversion. The number of lanes before and during construction was maintained. On Jalan Bulan, an area is allocated for diaphragm wall construction facilities. This is one of the busiest parts of Kuala Lumpur, requiring the relocation of utilities. From here at the Inai launch shaft, 2 variable density TBMs will tunnel beneath Jalan Bukit Bintang. Several buildings were cleared to create the construction footprint, which covers an area of approximately 11,000 square meters. Work started in September 2012. Grouting work began concurrently with Secant board piling for the lower and upper shaft from early October 2012. Excavation works for the lower shaft began in early 2013. When hard rock was exposed, rock blasting commenced. Rock blasting is carried out 2 to 3 times a day until the lower shaft reaches a depth of 45 meters. Pasar Rakyat MRT station is located at the junction of Jalan Tun Razak and Jalan Kampung Pandan. Secant board piling works began with groundbreaking in early 2013. The Pasar Rakyat station is the largest and deepest underground station for the Sungai Buloh Kajang line and is the only interchange station that will connect with future KVMRT lines. This station will be excavated to a depth of 45 meters and will churn out the largest amount of waste material in the entire project. To maximize the speed of excavation, a surface miner is brought in. This machine is the first of its kind in Malaysia. The Cochrane MRT station, which measures about 14 acres, has the largest construction footprint. Work started on-site in May 2012. The Cochrane shaft is the launching site for 4 variable density TBMs that will mine northwards and southwards. Secant board piling for the station wall was completed before control rock blasting began. The Cochrane site is both a station and a launch shaft and is excavated to a depth of 30 meters. Shotcreting of the walls is done while the station box is being excavated. The north end of the shaft was completed by January 2013 to facilitate the arrival of the first TBM. To prepare for the TBM assembly, a concrete shuttering pipe was constructed at the surface. It was slowly lowered into the shaft and set on a preset steel cradle. The shuttering pipe ensures that the TBM can pass through and follows the correct tunnel alignment. Concrete was cast around the permanently fixed shuttering pipe, forming a head wall, which was tied back to the existing rock face. The shuttering pipe has an outer flange with holes drilled into it. The seal ring was lowered down the shaft and bolted to the shuttering pipes. This is where the TBM seal ring is attached for launching. The first variable density TBM arrived in Malaysia at the end of January 2013 and was transported to the Cochrane site in early February for assembly. When all 4 TBMs are in operation, they will be supplied by a treatment plant which manufactures 4,000 cubic meters of bentonite slurry per day for the 4 TBMs. Located in Cheras, the Maluri MRT station and the integral crossover box measures 9.14 acres. Stage 1 of the station box construction includes traffic diversions, clearing of the Exit 1 site on Jalan Cheras, and secant board piling. Throughout construction, special equipment monitors nearby residential areas to make sure they are not affected by construction. As part of the traffic management program, a temporary bridge was constructed across Sungai Kerayong to divert traffic. The Maluri South Portal acts as the transition between the elevated and underground section of the line and as a shaft for retrieving the variable density TBMs from Cochrane. Preparatory works began on-site in April 2012. Secant board piling works at the portal began in January 2013. At the retrieval part of the portal, deep soil mixing is introduced to strengthen the ground, which will allow the TBM to be easily retrieved. The underground works for the KVMRT is progressing well and on schedule. All teams from MMC Gamuda KVMRT are working closely together to attain the highest standards and best engineering design.